Hello guys, and welcome to Java Tutorial 5. We're going to be covering Java primitive data types. It says that the Java programming language is statistically typed, which means that all variables must first be declared before they can be used. This involves stating the variable's type and name as already seen. So here we have a type called int, and then the identifier variable name is called gear, and the initial value that we store inside of this variable of type int is 1. It says doing so tells your program that a field named gear exists, holds the numerical value, and has an initial value of 1. A variable's data type determines the value it may contain plus the operations that may be performed on it. In addition to int, the Java programming language supports 7 other primitive types. A primitive type is predefined by the language and is named by a reserved keyword. So the int here is a reserved keyword, which is reserved for the Java language. Primitive values do not share state with other primitive values. The 8 primitive types supported by the Java programming languages are byte, short, int, long, float, double, boolean, and char. Some people call it char. All right, and all of these primitive types here have initial values. So the initial value for a byte is 0, the initial value for short is 0, the initial value for an int is 0, the initial value for a long is 0, float is 0.0, double is 0.0. So you can see that the first 4 primitive types here hold values of whole numbers, So they're integer values, right? And they don't hold any fractional numbers. The next 2 here hold fractional numbers, which are decimal numbers with fractional parts. This one right here holds characters. This right here is an escape character, which is the null byte. This we typically will not be using within the Java programming language unless you want to use it somewhere within your program. But when we go ahead and print this out, it's going to show that it's empty. Okay. Then this is going to be type string. This is actually an object, all right? And this is used to hold things like your address, your name, your social security number or something like that. You can put them in this as well. And then we have the boolean here, which holds the values true or false, okay? But these are going to be the initial default values for this field, all right? So there's a difference between having a field, right, or a member variable, and then a local variable. So you guys can see it says that local variables are slightly different. The compiler never assigns a default value to an uninitialized local variable. If you cannot initialize your local variables where it is declared, make sure to assign it a value before you attempt to use it. Accessing an initialized local variable will result in a compile time error. All right. So now what we're going to do is we're going to create a Java class, and then we're going to go through the primitive type variables. All right. So open up Genie, and let's go ahead and just create a new file, and then we're going to save it as primitive types. So we'll call it primitive types.java, and save it as the Java folder. And we can go ahead and declare the class. All right, so I have to go ahead and create main. Okay, so now we have main, right? You can just go ahead to and leave a comment. I'm just going to go ahead and write the comment, and then I'm going to be right back. All right, so I just went ahead and I did the same thing we normally do with the comment, is add the author, the file name, and the description for the program. All right, so now the first data type that we need to create is the byte data type. And the reason why Java has so many different data types or different primitive types to hold different values for whole numbers is because depending on the hardware that we're working on, we might have constraints on the values that we can actually assign or store within the hardware. So what Java does is have different primitive types that have different types of ranges. The primitive type byte only goes from the values -128 to +127. And then the short goes from -32,768 to +32,767. All right, and then an int goes somewhere over -2 billion to +2 billion. All right, so it goes from -2 to the 31st power to +2 to the 31st power -1. And then the long is 2 to the 63 minus 1, and -2 to the 63 minus -2 to the 63 power. All right. So depending on the range of the value that you want to store, you have to make sure that these values actually fit within the primitive type. So the smallest primitive type is byte. All right. So let's go ahead and create the byte primitive type. I'm going to give it the identifier or variable name as B, and they're going to give it the value 1. So now we can go ahead and just say system.out.print line, and then we pass in the identifier, right, which is the name of the variable, and then this should go ahead and print the value 1. So what we can do here is compile this and then execute, and we can see that we get the value 1 printed out. So what happens if we went ahead and we stored a value greater than 127? So let's use 128. So remember that the maximum number that we can store inside of a byte variable is 127 positive. So if we went ahead and compile this, you see that we do get an error here. So pretty much it's saying that, well, this is not going to be able to fit within this container. And then it's going to go ahead and throw an error. All right. However, if we change this from byte, right, let's take this back to 127. All right. So now let's create a new variable of type short. I'm going to call this S, and then we're going to give the value 30,000. So remember, the maximum value that we can store in here is 32,767. All right, so we can give the value 30,000, and that will fit. And then now, instead of us printing B, we can print out S, and we can go ahead and compile this and then execute, and then we're gonna get 30,000. Just like the other one, if we went ahead and try to print out 35,000 here and we try to compile this, it's going to go ahead and throw an error because the value is way too big, right? Just like if we wanted to go ahead and also do -35,000, it's also going to go ahead and still throw an error because the value is still big. So if it doesn't fit within the range that Java has specified for the primitive type, we're going to get an error, all right? So let's take this back to -30,000, and then we can go ahead and build and execute, and you guys can see that we do get the value -30,000. The next type is int. All right, I'm going to call this I, and int can hold values up to 2 million. So we can do something like this, put an underscore here, and then right. So if we look at the documentation down here, all the way down here, we can actually add underscores to values like this. All right, so if we had an int or a long value that was in bytes, right, and we wanted to prefix them with underscores, we can actually go ahead and do that. All right, so you can add an underscore to characters and to numbers, and you guys can see here that you can do this as well. All right, so let's go back here, and then we're going to pass in I and compile and execute, and we're going to get the value 2 million printed out on the screen. All right, so the next one and the last one is long. This is going to be L, and this can store 2 to the 63 power. And what we can do is we can use our math library, and they're going to use the power function or method, and they're going to pass in 2 to the 62. The reason I'm putting 62 is because we have to do 2 to the 63 minus 1 for it to actually be the right value. So I'm just going to use 62 here, and then what we're going to do here is pass in L here. Okay, and typically the power function, that should be fine. So let's go ahead and compile this. And this is going to go ahead and give us an error. The reason is because we have to go ahead and do something called a cast. I know this is going to be something I was going to cover in the next tutorials, but I guess I'm going to have to show this here. And then we're going to compile that. And once we execute this, it's going to give us this huge number. All right. So this number right here is bigger than the 2 billion that we can store in the int. It's actually way bigger. Right, it's about double the amount that we can store in the int. So if you wanted to, work with something that was really huge, and what variable, what primitive type to use, int or long would be the safe one to go. All right. Typically, most Java programs just default to int anyway. If you look at the way that the Java compiler works, all of the initial numbers are actually int, and then when you go ahead and want to use other data types, it is then converted to that data type. And this is something a little bit more advanced when you're looking into the compiler. But eventually, when I get to like tutorial 80 or something like that, I'm going to cover those. All right, so we can cancel this here and just put some long number. All right, so most of the time it's good to prefix this with the L you see here to dictate that this is going to be a long value. And this is actually part of the documentation. Let me see where that is. So if we have a float value, we can actually put F. If we have a double value, we can put D. So for float, we can put the F letter or letter this thing. Or for the double, we can use D. For floats, for long, we can use L. Doesn't say here, but we can use L. So let's go ahead and build this and execute. And you guys can see that the long value that we specified down here is actually printed to the screen. All right, the next two primitive types we're going to be learning are going to be for the real numbers. All right, so these ones right here are for whole numbers or integers. All right, and this one will cover real numbers. So for things like pi, right, or 1 point something something something, or for e, it depends what you want to store in it, but it has to be a decimal point number. All right, so we have the first one is going to be of type float. All right, and we're going to give the identifier name as f, and this is going to equal to 23.12345. All right, and remember that you can either add in the capital F or you can add in the small f here for float. Now we can go ahead here and pass in f and compile, and we can execute this. And this is going to go ahead and print the 23.12345. All right, so what's the difference between the double and the float to store real numbers? One possible reason is the amount of decimal places that you can store, right, in the float variable here. The maximum is 7, so you can store up to 7 after that. So let's try to compile this and just run it. All right, so even though I have way more 6s than I have here, you can see that it only went ahead and printed out 6 actually. So it should be 6 decimal places after the dot. I thought it was 7. All right, so it's 6 decimal, oh, it printed out 6 decimal places. While the other one for double, we should have up to 15 decimal places. Hopefully I'm right with that. All right, so we're gonna do 45 dot go 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. All right, and they're going to add in capital D or lowercase d for for double. And then let's go ahead and pass in D. All right, so now you can compile and execute. And as you guys can see here, that it actually went ahead and printed out all the decimal, the numbers after the decimal. If I went ahead and added in 7 here, and then we compile that again and execute, you can see that the 7 is never printed out. That means that the cutoff for the decimal spot here was 15 values, and here it's 6 values. I really thought this was 7 values. All right. Okay, so since we've covered that, we have to cover the character data type. All right. So the character data type is called char, and we're going to call this one C, and we can store values in there like R. All right. So to store, this only stores a single character, and for us to define a character, this goes in single quotations. All right. So this is going to store the character R, so we can go ahead here and pass in C, and then we should print out the character R. So we're going to compile it and execute, and you guys can see that we do have the character R printed out on the console. All right, and then the last one is Boolean. So Boolean is used to print the, so let me go ahead, and this one is for character, and this one is for true, false, on, off. All right, so it's Boolean. We're gonna call this one B, and it's gonna take the value true. So you can use the value true, and then we go ahead and pass in B here. We have to compile it. Every time we change something, we have to compile it and then execute it. So compile. So Boolean B. Did I use B somewhere? Yes, I did. So my bad. One more thing. You cannot have 2 variables of the same name, right, with 2 different types. What happens is they have a conflict in name, so we're gonna have issues in there. So what I'm gonna do here is gonna put the value. I'm gonna put the name as bool and change this to bool. All right. So now we can compile this and execute. And this should go ahead and print out the value true. All right, so we have one more data type, but this is of type object. Okay, this is an object data type, and it's of type string. All right, so strings are used to store things like your address. So we can put something like, or name of a city or a state. So we can say something like New York. All right. And then we have to create another string called, let's say another string, let's say str1 gonna equal to California. So this is my state. All right. And so forth. So now what we can do is that we can go ahead and pass this. So we can pass in str, and then we're gonna create a space and then use the plus sign, and we can pass in empty strings to this function. So this method here, print line, can take in arguments as str, and then this plus right here is not the plus that we normally use to add numbers. This plus is used to actually concatenate strings. Okay, so this is going to be used to print out this. So this is going to print out the value New York, and then it's going to go ahead and add a space. Then it's going to go ahead and try to concat anything to the right side. So what we're going to do is pass in the next string, which is str1. So what it's going to do is going to print out New York space California. So let's save this and compile. So you guys can see it prints out New York space California. So what happens if we never added this space in between and we just had this? So what it's going to do is going to have New York. It's going to have York and the California like bind right next to each other. So let's go ahead and compile this, execute. So you guys can see here that we have New York and California right next to each other. So this is used, the plus here is used as string concatenation. All right, concat means to put together. All right. And this is going to go ahead and pretty much cover all of the Java primitive types plus the one data type, which is of strings. And with this, we can start doing some really fun stuff. So what I'm going to do next tutorial is show you guys how to get the maximum values for each primitive type using their wrapper classes. Alright guys, I'll see you guys in the next tutorial. Have a good day. Bye bye.